Hi grade 9s. Today we are going to go through lesson 4.2 and the topic is static electricity. So you've got the notes in the package that you had there, so you're just going to fill in the blanks there and then we're going to draw some diagrams underneath that. Okay, so first off, static electricity. Now you would have done, hopefully you were able to do that little demo that was in your textbook there with the comb. So static electricity, we all have experiences with static electricity. And what they are electric charges that are stationary. So this is what you need to write down in your notes there. Electric charges that are stationary. So stationary means they don't move. And so when something carries a charge, it has static electricity. So this would be in opposition to a circuit, for example. So if we have a current of electricity, that is different from static electricity. So static, they're not moving. Now we've got models for charges here. So we have the particle model of electricity and we've got the atomic model. So the atomic models coming from our chemistry unit that we took at the start of the year here. So particle model of electricity, we've got positive or negative charges, and in the atomic model we call them protons and electrons. In the electricity model we gain or lose charge. In the atomic model, we gain or lose electrons specifically. In the electricity model, positive charges don't move, and that is the same for the atomic model here, in that protons don't move from the nucleus, right? So the protons are trapped inside the nucleus, only the electrons move. So you can make sure you copy down all that information there, and then we're going to look at a demonstration of pith balls. So hold on here. Okay, now this, I have to switch screens here. So a pith ball, first of all. Okay, so if we look at, well, we've got this little ball here. So that is called a pith ball. So it's a metal round ball, a metal sphere. We're gonna skip this one. Hold on. Okay, don't worry about this one. Okay, what that means is that ball now has a charge. Okay, so let's start here. So what he's doing right now, by touching the ball like that, he's grounding it. And so when you ground something, you're making it have a charge to be neutral, that you're neutralizing the charge. And so yesterday you would have learned about how like charges repel, right? So a positive and a positive repel, for example, whereas unlike charges attract. So like and unlike charge, so a positive and a negative, they're going to attract each other. Sorry, excuse me. So this ball, you would have also discovered that neutral objects are attracted to charged objects. So right now, what he's doing with his hand, he is grounding that pith ball. Okay, so now it's going to have a neutral charge. Now the rod here, he's rubbing it against fur, and what that does is it causes it to have a static charge built up on it. So now, look what happens. So it's being attracted and, touches. And when it touches, there's a transfer of charge, a transfer of electrons. And so now both of those objects have a negative charge, which is why that rod is repelling now, is repelling the pith ball. So they touched, we had a transfer of charge happen. So now he grounds it again by touching it. And you can go ahead and do the same thing again. So again, now it's going to repel because they both have the same charge. There was a transfer of electrons, transfer of the negative charge. I think that's it, yeah. Okay, now we are going to go through pith ball demos. I'm going to draw them out for you, but also when you come back to school in a couple weeks, we have pith ball apparatuses here, and we're going to go through, and you have a chance to play with them because they're actually kind of fun. Anyways, okay, so what's happening here? So we've got this diagram up here. Hold on. There we go. Up here. So the rod ends up having a charge, right? So he charged up the rod, and then what that causes, that causes there to be a charge separation in the pith ball. Okay, hold on here. There we go. Okay, so, geez, I'm going to show you diagrams of when we bring the rod close to the ball, and then after that when we touch. So you're going to have to draw these in. Now I realize I should have given you more room, so don't draw your diagrams really big because we need to put a fair bit of stuff in there, and I really should have made it bigger. Anyways, nearby. Okay, so first of all, let's, okay. So if we bring it nearby, I'm going to divide this up into 2 frames here, like a comic strip. Look at that. So we're going to bring the rod near a ball. Now the ball has a neutral charge, right? So this is the pith ball. So neutral charge, so I'm going to give it positive, negative, positive, negative. I'm just going to draw 4 just to and draw them equally just to represent that they're equal here. Now, when you bring the rod near it, so this rod was in the diagram, in the video that I showed you, when you rub the black ebony rod with the wool, it ends up having a negative charge. So we're collecting static electricity on that rod, so it's got a negative charge. So what happens, so this is frame 1, what happens when we bring that rod close to it, it's going to be attracted to it. Now I'm just going to redraw the rod here. So these are my negative charges here. Oops, that's a negative charges. So the pith ball is actually going to be attracted to that rod. Now, what you end up seeing happen here in the pith ball, you end up seeing a separation of charge. So the negatives want to get away from that negative rod because those are opposite charges, and we know that opposites don't like each other. They're going to repel. Whereas the positive ones are going to be then remain in place, and so they're going to be attracted to that negative rod. So that's why we have the direction of the pith ball is that it's going to be moving towards the rod. And then here, this is called a charge separation. So a charge separation happens here. So that's why we have the attraction, the charges separate, and so we have part of the pith ball is positive, and that positive part is really attracted to that negative rod there. Okay, so this is the nearby demonstration. So nearby demonstrations, we've got a charge separation. Now, just so you know, if this was, now the pith ball is made of metal, so the pith ball is a conductor. If we had an insulator, so if it was an insulator, we know that things that are insulators like paper are also attracted to those charged rods. So what we would do then, in this case, we have, instead of a charge separation, we end up having what's called a charge polarization. So we've got a charge polarization happening there. Okay, so this is the nearby. So if in an insulator, we call it a charge polarization. Conductor, we call it a charge separation. They essentially work exactly the same. We just use different language for them. Okay, now, if we touch them, we see something else happening here. So again, I'm going to draw this pith ball, and the pith ball is attracted, right? So we're going to set it up the same. And then we've got the negative rod here, and it's going to be touching the ball now. So looking at that, when it actually touches, let's make sure that they're touching there, we have a transfer of charge happening in this one. So we've got a charge transfer. So when that happens, the electrons are going to move. Now it's important to remember here the protons or the positive charges do not move. It is only the negative charges that move, okay? Now when these two things touch, the negative charges on the rod are going to be very attracted to these positives in the pith ball here. So they're going to jump. They're going to leave the rod and jump onto the pith ball here. So we have electrons moving at this point. Now, once that happens, I should have actually done two screens here. Once that happens, then we have a situation where the rod is still negative. So it lost negatives, but it still has a bunch of them. And the pith ball now, if it has extra negatives, what charge is going to be on that pith ball? Yeah, it's going to be negative. So now if the pith ball is negative and the rod are negative, what do we know is going to happen? There's similar charges or like charges, so we know that they are going to repel. So now we're going to have to draw the pith ball moving in the other direction because it doesn't want to be near that negative rod any longer. And so now I'm going to draw here more negatives than positives because this ball is now negative, the rod is negative, and they're going to repel each other, okay? So when we touch like that, we've got a transfer of charge, and so the rod caused the ball to become negative. Now, the same things happen. Now, say we had the rod being positive. So now, and that can happen. So say the rod was positive. When the pith ball would be touching, now here we'd have the negatives lined up close. In this case, now again, the positives do not transfer, right? Only the negatives. So what would end up happening, you'd have that electron and it would actually jump onto the rod, leaving that pith ball with an overall positive charge because it lost electrons, right? It lost the negatives. So you'd see the same thing happen. So visually, you wouldn't be able to tell a difference, but you would know that the charges were just different and opposite there. Okay, so we are going to go over these concepts again. So draw these diagrams in your notes here. We are definitely going to go over them again when we have our meet tomorrow, so you can be ready for that. Yeah, okay, in your assignment, you're gonna do just 2 questions, so not very much. In your textbook, page 219, questions 5 and 7. Okay, thanks everyone.